Ovista, revolutionizing eye tracking software for education, health, and legal applications. Affordable, flexible, and modular solutions.
Generally speaking, there are two basic premises that our brain needs to abide by. First off, our senses continuously provide our brain with an enormous amount of information. And secondly, our brain only has a limited amount of resources to process all of this information. How does the brain solve this apparent problem? Through a filtering process, also known as selective attention. To put it simply, the brain filters the sensory input so that fewer sensory inputs are processed a lot, while the rest receives little to no processing. What influences what we attend to? Our perception is influenced by internal processes. Let's try a little exercise. Find the yellow triangle in the following picture. You didn't have to look specifically at all the objects to find the yellow triangle. Instead, the imposed search goal made your attentional system more likely to detect triangles, as well as yellow objects in your visual field. The exercise illustrates how our perception is partly shaped by our current goals, since our goals influence the likelihood of us noticing certain stimuli over others. Welcome to this session on visual attention. Visual attention and visual perception are not the same thing. In this video, we will look at why it is relevant to distinguish between the two. The phrase attention is often used in everyday language, and more than 100 years ago, William James stated that attention is the taking possession by the mind in clear and vivid form of one out of what seems several simultaneously possible objects or trains of thought. And perhaps more importantly, he also noted that it implies withdrawal from some things in order to deal effectively with others. Let's take an example. What do you see? A young woman or an old lady? It can be difficult to spot both women, but one thing is for sure, you're not able to see both of them at the same time. Let's have a look at one more example. A duck or rabbit? These examples illustrate that there's a difference between what visual input goes through your eyeballs and the meaning you extract from it. In order to understand the basics of visual attention, we have to know more about the inner workings of the human eye. Our eyes make 3 jittering movements per second, even when we focus on an object. In this particular sense, the eye is not very comparable to the camera analogy. The reason for these involuntary movements is that the photoreceptors continuously need to be activated with new stimuli in order to continue sending visual signals to the brain. In the case that our eyes were totally still, we would actually end up seeing nothing at all. In professional terms, viewing is divided into saccades, which refer to our eyes' movements, and fixations, which are the sequences in which our eyes are fixed on an object for a period of time. The average fixation time is between 150 milliseconds and up to 600 milliseconds. A saccade can be short or long. It can last between 10 milliseconds and up to 100 milliseconds. When people are reading body text, meaning text in sentences, they have fixation times as low as 50 milliseconds.
How our software detects learning and cognitive challenges. Recognizing conditions through eye tracking. Learning difficulties, e.g. dyslexia, metric, slow reading speed, short saccades, and frequent regressions. What it means, struggling readers take longer to move their eyes between words and often read previous text. Example, a student may fixate 2 times longer on words compared to typical readers. Autism spectrum disorder, ASD. Metric, reduced focus on social cues like faces or eyes. What it means, difficulty in maintaining attention on relevant stimuli, e.g. teacher's face or text. Example, a child may focus more on objects than people in interactive tasks. Alzheimer's disease. Metric, long fixation durations and abnormal saccade patterns. What it means, delayed gaze transitions indicate cognitive processing issues. Example, difficulty scanning and remembering visual information, e.g., reading a clock, stroke recovery, metric, gaze disparity and neglect of one visual field. What it means: limited awareness of one side of the screen or text due to brain damage. Example: a patient may only read the right half of a sentence. How our software helps: tracks eye movements like fixations, saccades and regressions during simple interactive tasks. Highlights abnormalities automatically and generates easy-to-read reports. Provides progress tracking for therapy and interventions over time.
Who we are. We are Ovista, a pioneering team combining expertise in social psychology, business strategy, and software development to create the next generation of eye tracking solutions. What is our vision? To bridge the gap between complex data and actionable insights, making eye tracking analysis accessible, meaningful, and practical for all users.
Tobii offers detailed data but is often too complex, while Lexplore is simple but lacks flexibility and adaptability. Ovista combines the best of both, offering powerful analytics like Tobii with the simplicity and customization of Lexplore, all while supporting diverse hardware and applications across education, healthcare, and legal sectors.
1. Student Learning Package. The clients are teachers and psychologists. 2. Stroke Rehabilitation Package. What our clients are: physicians, 3. Alzheimer's and Cognitive Impairment Package. For our clients in neurology and research areas. 4. Legal and Insurance Package. Our clients are lawyers and investigators.
Join us in revolutionizing eye tracking. Partner with us to bring flexible, impactful solutions to education, healthcare, and legal industries. Let's shape the future of eye tracking analysis together.